In this video, we will be using the second derivative test to examine the concavity of a function. This first example is a piece of a curve that's concave up, and this example is a piece of a curve that is concave down. The graph of a function f is concave up if the second derivative is positive in a given interval. The graph of a function is concave down if the second derivative is negative in a given interval. To use the test for concavity, we first locate x values where our second derivative is 0 or where our second derivative does not exist. Then we determine test intervals and test the sign of the second derivative in each interval. The example that we'll be doing is determine the open intervals on which the graph of f of x equals x to the fourth plus 6x cubed is concave up or concave down. So we need to find our second derivative. Our first derivative is equal to 4x cubed plus 18x squared. Our second derivative then will be 12x squared plus 36x. Now we need to locate x values where this second derivative is equal to 0. I'm going to factor out 12x. And I'll end up with x plus 3. Alright, the product of two numbers equals 0, then one of the numbers has to be 0. So 12x equals 0, or x plus 3 equals 0. Solving for x, divide both sides by 12, we get x is equal to 0, or x is equal to negative 3. Right. So our intervals, let's mark this as negative 3 and 0. So we have an interval here, an interval here, and an interval here. We can pick any test value as long as it's in that interval. So let's use a test value of negative 4, a test value of negative 1, and a test value of 1. So we want to test the value of our second derivative. With each of those. I'm going to enter my second derivative in the calculator. ignore that number for right now. Let me insert -4 and store that in the memory for x. And we see then that the value when x is -4 is 48. We store -1. And I get -24. And then let me store +1. And I get 48. So my second derivative here is positive, therefore concave up. My second derivative here is a negative, therefore concave down. And my second derivative here is positive, so concave up. My directions asked me to determine the open intervals on which the graph of the function is concave up or concave down. So I can say concave up from -infinity to -3. Concave down from -3 to 0. And concave up from 0 to infinity.